Swayam Prabha. Digital India. Educated India.
Now, I am going to explain about connectionism and folk psychology. There are many philosophical problems are existing in connectionistic model of mind, and secondly, whether this connectionistic model of mind replacing folk psychology, and connectionism plays vital role to solve many kind of scientific as well as our day to day problems. But when connectionism is trying to explain mind in terms of connections, units, nodes, and synaptic relations, then the philosophical questions arises, then it replaces folk psychology, then it explains folk psychology in ordinary way. Although this connectionistic model of mind is part of the also one of the cognitive model of mind which we have seen, and connectionism is one of them also. In the modern cognitive science, these models have provided the basis for simulating or modeling a cognitive performance. Simulation is one of the important ways of testing theories of the mind, and if a simulation performs in a manner comparable to the mind, and then that will offer support for the memory underlying that simulations. However, in cognitive science, we see that two models have provided a basis for most of the simulation activities. And there are two models in the simulation activities if we find in the cognitive science. On the one hand, if you see, the digital computer can be used to manipulate symbols, and insofar as it becomes possible to program the symbol processing computer to execute a task that seems to require intelligence. That is, the symbol processing computer becomes a plausible analogy of the mind. There are various cognitive science theorists have been attracted to the proposal that the mind itself is a symbol processing device. The model of the brain, on the other hand, is a technique, anatomy and physiology of the brain, and this view suggests that the brain consists of a network of simple electrical processing units which can simulate and inhabit one another. This style of explanation of the brain in the cognitive science is generally considered as the brain style computations. Now, the question is, why should there be a brain style computations? And there are many connections. They have replied to these questions very scientifically, and they say that the basic assumption is that we seek explanation at the program or functional level rather than the implementational level. Thus, it is often pointed out that we can learn very little about what kind of program a particular computer may be running by looking at the electronics with which it is made. In fact, we do not care much about the details of the computer at all, but all we care about program that is running. And if we know the program, we will know how the system will behave in any situation. It does not matter whether we use vacuum tubes or transistors, that is the essential characteristic of the same. Between both the things, even if vacuum tubes or transistors, the essential characteristics are the same because it functions in a mechanistic way. And it is true for computers because they are all essentially same. Whether we make them out of vacuum tubes or transistors, we invariably use computers of the same design. But when we look at essentially a different architecture, and we see the architecture make a good deals of differences, it is the architecture that determines which kinds of algorithms are most easily carried out on the machine in questions, and it is the architecture of mechanism that determines the essential nature of the program itself, and thus it is reasonable that we should begin by asking that we know about the architecture of the brain and how it might shape the algorithm underlying the biological intelligence and human mental life. The way we have been understanding a architecture, in the same way we can understand in the biological intelligence and human mental life, and the way even the algorithmic process is going on in the this computational way, and the same way this biological intelligence and human mental life is going on. And one of the propaganda of this thesis is Rummel Hutt is one of the founder of this thesis. He says that the basic strategy of the connectivity approach is to take the neurons as the fundamental processing units. Neurons as the fundamental processing unit, that is one of the important things according to Rummel Hutt. And we imagine that the computation is carried out through simple interaction among such process units. Then essentially the idea is that these processing elements communicate by sending numbers along the lines and connect the processing elements. This identification already provides some interesting constraints on the kinds of algorithms that might underlie human intelligence. A question may arise here: how does the replacement of the computer metaphor as the model of mind affects our thinking? Rummel Hutt has given one plausible answer, says that this change is in orientation leads us to a number of considerations that further inform and constrain our models of building efforts. And because neurons are remarkable relative to the components in modern computers, and he says that neurons operate in the time scale of millisecond, whereas computer components operates in the time scale of nanosecond. Here there is a huge difference between speed between brain and a computational system, and even if a computational system is more faster, because the computer system is running in the time scale of nanosecond, but in the case of a human brain is functioning in the time scale of milliseconds, and this distinction is a very vital distinction, and this shows that computer is superior to human mind, and if this is superior to human mind, then consciousness can be explainable in this level also, and even if this consciousness can be quantified, and this quantification consciousness can be explainable in a mechanistic way or in the connectionist model according to Rummel Hutt. And this means that human brain process that receives the order in a second or less can involve only 100 or so times steps, because the most of the computational process like perceptions, memory travel, etc., take about a second functions. That is, we seek a explanation of these mental phenomena that do not require more than about a 100th elementary sequential operations. The human brain contains billions of such processing elements. As the computer organizes computation with many serial steps, similarly the brain can deploy many processing elements cooperatively and in parallel to carry out its activities. There is a cooperation is there, and there is a parallel is there, and that way it is functioning. Thus, the use of brain style computation system offers not only a hope that we can characterize how brain actually carry out certain information processing task, but also offer a solution to a computational problems that seems difficult to solve in traditional computational framework. In the traditional system, it is very difficult to measure how a brain is functioning and in what level consciousness is there. But in the connectionist model, according to Rummel Hutt, that we can able to solve even the computational problems with the help of this model, because this model shows that there is a mechanistic system is functioning faster than the human brain. Therefore, we can able to solve some problem in computational model of mind. The connectionist systems are capable of exploiting and mimicking brain style computation like artificial intelligence also. And they have been trying to mimic this artificial way, and connexionistic operates both as a system and a process also. The connexionistic systems are very important because they provide good solution to a number of difficult computational problems that seems to arise often in models of cognitions. Connexionism as a process mechanism is carried out by a number of processing elements, and these elements called nodes or units have a dynamic which is roughly an analog to simple neurons. Each node receives inputs from some number of nodes and responds to that inputs according to a simple activation functions, and in turn executes or inhabits other nodes to which it is connected. The above analogy will be very clear if you go through the connexionistic system. Let us see a figure. In this figure, we have taken arbitrarily as a connexionistic model. In any connexionistic model, there are 3 units as input units, hidden units and output units. And here the input units are as such ISTHEMAONR, and the hidden units are each, the, mat, on and rat, and the output unit is the rat is on the mat. There may be many inputs, even if many hidden units, many other output units. The hidden units serve neither as input nor as the output, but facilitate the processing of information through the system. And this model will be very clear if you go through Ramal's 7 major component of any connexionistic model. There are 7 components of any connexionistic model. First major component is a set of processing unit. Any connexionistic system begins with a set of processing unit. All of these processing units, connexionistic system is carried out by these units. There is no execute or other agency. See, there are only relative simple units, each doing its own relative simple job. A unit job is simply to receive inputs from its neighbor. As its function, it sends outputs values to its neighbor. The system is inherently parallel in the sense that units can carry out their computational process at the same time. Whenever it is passing, getting information and giving the informations, in that process also computation are there at the same time. There are 3 types of units, and inputs units, output and hidden units. Input units receive inputs from sources external to the system under study, and the output unit sends signal out of the systems, and the hidden units which are check the inputs and which check also output within the system they are modeling, and but they are not visible to the outside system which is hidden inside the system. And secondly, the state of activation, and in addition to the set of units, we also need representation of state of at a time. Know what time we are activating particular unit, and this primarily specified by a vector time representing the pattern of activations over the set of processing unity, and each element of the vector stands for the element of one of the units. It is the pattern of activation over the set of units that capture what the system represents at any time, and it is useful to see processing in a system as the evolution through time or pattern of activities over the set of units. And thirdly, output of the units, and units interacts by transmitting signals to their neighbors, and the strength of their signals and the degrees to which they affect the neighbors are determined by their degree of activations. The output units also depends on the on its activational values and how much inputs we were given, and it depends upon the output values also. The pattern of connectivity, there is a pattern of connectivity among the different nodes in the unity. Specifically, all these processing functions not in the arbitrary way, but in the pattern of connectivity among the processing unity, and that processing unity is there is one kind of pattern of connectivity is there, and it will respond arbitrary to particular unit. It is not necessary to give. If you put something, then it will automatically will get the exact result from the output. And activation source, we also need to set up rules where the inputs impinging on a particular units are combined with one another, is undergoing processing with the current states of units that produces a new states of activations. 6.3, modifying a pattern of connectivity as a foundation of experience, and it can develop new connections, loss of existing connections, and modification of the strength of a connection that are already exist. Modification is there, and it may get new connections automatically, it may modify the changes and get also strength of the already that modification of the strength of connection that are already existing. Lastly, representations of the environment. For the development of any model, it is very difficult to have a clear representation of the environment in which this model is to exist. In connectivity model, we represent the environment as a time making stochastic function over the space of input patterns, and that is, we imagine that at any point of time there is some probability that any of the possible set of inputs patterns is impinging on the inputs units also. This probability depends on the history of inputs as well as the outputs of the systems, and in practice most models involve a much simple characterizations of the environment. And now we have to see some of the philosophical implications of connectionistic model of mind. There are many philosophical problems which are existing in this connectionistic model of mind. In the understanding of cognitions, connectionism will necessarily have implementation of philosophy of mind, because it is also explaining mind in a mechanical way. Because of that, philosophers are reacting against this thesis. There are also two areas in particular in which it is likely to have impact. And there are analysis of the mind as a representational system. Even if connectionistic model of mind is like a representational system, analyzes functional intentional representations which further distinguishes in the computational theory of mind from the representational theory of mind. And further concept of this representation we will see in the next sections. As we have seen, the representational theory of mind holds the view that systems have mental states by virtue of encoding representations and stating in particular relations to them. The computational theory asks that cognitive activities consist of formal operation performed on these representation system. Further argument against connectionism brings out the defects of the connectionistic model. He opines that it fails to support the computational theory, because further interprets connection model as representational, and so potentially conforming to the representational theory of mind. And this is because connectionists routinely interpret the activation of units or groups of units as representing contents, and here there is no distinction between the connectionistic model of mind and the representational model of mind. And you see the way representational model of mind representing something, the symbolic process system, in the same way connectionistic model mind is doing. And this is the case of inputs and output units providing cognitive interpretation of networks activity, and thus the theorist must treat the input as a representation of a problem and the output as a representation to the answer. And even if whenever the problem arises, we give the inputs and we get the answer is like the output, and a given unit is found to be activated by units with certain features and so interpreted as representing those features. And this suggests that connectionistic system can indeed be understood as a representational theory of mind. Even if connectionistic networks exemplify the representational theory of mind, they are significantly different from more traditional example of the representational theory. Firstly, it is not clear that we can always give an interpretation what units in a connectionistic network represent in natural language terms. Secondly, the representations that are concerned are not discrete but it is distributed, and that is the same unit and the same connects many different representational role rather than employing one representations per role. These distributions connectionist representations from those that have previously been designed. And thirdly, it is emphasized that the pattern of activation on the hidden units in connectionistic system are the products of the learning that the system has undergone, and the interpretations assigned to these units are not arbitrary. They are represented symbolically, but are analysis of how the network has solved the problems it was confronting, and thus the network is connected to sensory inputs and not supplied inputs by modular machinery. The intentionality of these representation is genuine, not merely a product of these theorist interpretations. Therefore, it is like a representational model of mind according to Jerry Fodor. Now, we have to see whether this connectionistic model of mind contributes to the replacement of folk psychology. Folk psychology generally we mean the ordinary people believe about desire, about the concept of mental things, about the mental activities of mind. That is why it is a folk, and it is not a scientific or it is not a classic way of explaining mind, but it is a folk way of explaining mind, the folk psychology explaining that way. Whether this connectionistic model is replacing folk psychology, even if you see it is replacing the folk psychology, because we know that in many ways cognitive science is originated from philosophy, and the importance of connectionism to philosophy emerges first with respect to the question whether folk psychology remains viable or must be replaced. If it is replaced, then the reliance on proposition and representations of knowledge in other areas of philosophy would be at risk, because even if we are replacing folk psychology, it is also replacing phenomenal mind also and qualia also, because connectionism explain mind in terms of a mechanical process, and it leaves out the mentality of the human mind, and this theory suggests that there is no mental quality such as belief, intention, etc., the way we ordinarily think about the human mind. If connectionism should provide a correct account of mental processing, if it did not turn out to implement symbolic systems, the accounts of mental life as actually involving the manipulation of propositions would appear to be false, and that is the mental states involves propositions will not figure in the genesis of behavior. And here I would like to one of the important points which has been raised by William Churchland, that eliminative materialistic says that even if like connectionistic model of mind, there is nothing called mind at all. Eliminative materialism, by maintaining that if a theory fails to reduce our best scientific theories at low level, it must be dismissed as false. And the eliminative materialist says that we should eliminate concept of mind in the when we are explaining brain or any other scientific thing. There is nothing called mind, they are eliminating, completely mind is not there for them. They contend that the reduction of fails in the case of folk psychology, because there is nothing in the head with which to identify the propositions it posits. This conclusion entails the further proposition it posits. This conclusion entails the further conclusion that folk psychology is false. Even if not only connectionistic model of mind says that folk psychology is not there, you can replace the folk psychology. In the same way, eliminative materialism also said that. In making this inference, and according to many philosophers, it is in making this inference they assume that folk psychology theories about process occur inside people's mind. Now, we have to examine the question whether connections contribute to the replacement of folk psychology. As we know, folk psychology refers to a people's attributions of propositional attributes to other people and uses these to predict and explain their behavior. And these attributions are made to whole persons, that is folk psychology does not itself offer an account of the finer gained internal operations that may produce propositional attitudes. If we attribute to a person a particular belief that itself need not be a discrete internal state, that is the state inside the person that enable the person to have a belief with will have a quite different character, and they apply the above point to the case of cognitions, because the activities inside the head may make it possible for a person to have a beliefs and desires, but it does not assume that they have internal states and correspond to these proportional attitudes. It may be the case that the internal activities are best described in the cognitionistic approach. However, if you see, it does not show that folk psychology is false, because if you see, but if it is false, it will be so because it does not give correct characterization of the cognitive state of persons, and must therefore be replaced by a better theory at the same level. I would like to argue that the cognitionist model of mind is unable to refute folk psychology, because the cognitionist explains mind in terms of syntactic and thereby neglect the semantics, and which is very important for understanding the human mind, and this is the mental content which represents the world, and that is to say that there is a central agency of the I to which the mental activity is ascribed. This shows that human mind has propositional attitudes about the world, and there is a regular relationship between human mind and the world. As David Chalmers points out, which are the mental states such as belief, doubt, etc., often called as propositional attitudes, are attitudes to the proposition concerning the world. It is not, even if it may existing, it may not existing, but anything whatever we do about the activity about the world. Even if about the ourselves, we also part of the world. Therefore, there is a constant relationship between mind and world, and if there is a constant relationship between mind and world, it is very difficult to replace the folk psychology. This is one of the important point for folk psychology to argue against connectionistic model of mind. For example, when I believe that John will tour India, I endorse a certain proposition concerning John. When I hold that John will tour India, I have different attitudes toward the same propositions that John will tour India, and here the central feature of these mental state is their semantic aspect or intentionality. That is, a belief has a semantic content. Content of many beliefs cited is something like propositions that John will tour India. This semantic or intentionality aspect has the feature of subjectivity and qualia, and the subjective consciousness is an essential feature of mental states, and which can prove that the analogy of mental state is an irreducible fact of first person ontology. Whereas, in the case of connectionistic model of mind, there is no subjective experience, and it gives the explanation of mind in third person perspective.